Alright, so here's my fourth example for the washer method. Uh, so what we're doing is we're taking a graph and we're going to revolve it about an axis and find the volume. Okay, so the volume is pi times the integral a to b of big R of x squared minus little r of x squared. So big R is the outer radius, okay, and the of the rectangle, and little r is the inner radius of the rectangle. And once you find those, you just plug them into here and integrate. Alright, so let's take a look at this fourth example. Alright, so find the volume of the solid form by revolving the region bounded by the graphs of y equals square root of x and y equals x squared about the x-axis. Alright, so let's go ahead and draw our graph. Alright, so the square root of x, that graph looks something like this. Okay, and the graph of y equals x squared looks something like this. Okay, and you can see they intersect here. Okay, we're revolving this region here about the x-axis. Okay, so let's go ahead and put our rectangle in there. Remember, when you're doing the washer method, your rectangle is going to be perpendicular to the axis that you're revolving it around. Alright, so we need the outer radius and the inner radius. Okay, so the outer radius, which is this, that's big R, and the inner radius is this, that's little r of x. Okay, alright, so let's see what we have. We have big R, well, this radius here, okay, from here to here, this is the axis that we're revolving it around. So the bigger radius, well, that's this curve, so that's going to be the square root of x, and the little radius, little r, is going to be this curve, and so that distance is x squared. Remember, the big R and little r, that's the distance from the axis you're revolving it around. Okay, so, and also we need to know this x value. We know we're going from 0 to some point here. Okay, so to find that, what we're going to do is set these two equal to each other and solve for x. So I have square root of x equals x squared, and so I square both sides, move the x over, okay, so I get 0 and 1. Alright, so now I know there's 0, and then they intersect again here at x equal 1. So there's my limits of integration. Alright, so now I need the big R of x squared minus the little r of x squared. Okay, so the big R, that's square root of x squared minus little r of x, which is x squared, and that's squared. So I know this is equal to x minus x to the fourth. Alright, so that's going to give me my volume is pi times, and I'm going from 0 to 1 of big R squared minus little r squared, which is which is this. Okay, and so that's x minus x to the fourth dx. Okay, and so now I integrate. I get 1/2 x squared minus 1/5 x to the fifth, and I'm going from 0 to 1. Alright, so now let's evaluate. That's going to be pi times, that's 1/2 times 1 squared minus 1/5 times 1 to the fifth minus 1/2 times 0 squared minus 1/5 times 0 to the fifth. Okay. And once we plug all of that, you can plug it into a calculator or you can evaluate it by hand. That's going to give us 3 pi over 10. Okay. Alright, so that's my that's the fourth example. I hope it helped. And if you like my videos, you can subscribe and watch my other videos. Alright, thanks.